Hi, welcome back to another video. So today we'll be looking at carbonyl group. So these believe organic compounds that contain the organic group and that contain the carbonyl group, right? So a carbonyl group is just a carbon atom which is double bonded to an oxygen atom, right? And this is the way you write it. You have C double dash O, right? And that's your functional group for the carbonyl group, right? And its uses in everyday life is that it's used in flavors to, so in the food industry to create flavors. It also has pleasant smell, so it's used in perfumes and also in freshness, right? So as you can see, a lot of organic compounds are used in the fragrance industry, right? So it's also used as a fragrance as a solvent. An example is a nail polish remover, right? And it's also used to make glues. Then the general formula for carbonyl group compounds is CnH2nO. And we have two types, right? We have the aldehydes and we have ketones. So let's excuse. And the difference between these two, the aldehydes and ketones, it's the position of your functional group, right? Which results also in the difference of the naming of your compounds, right? So for aldehydes, the carbonyl group uh, is placed or bonded uh, placed at the end or the terminal at the end of the root chain, right? So we can say that actually I don't like how this looks, so let's just yes. Okay, so it's placed at the end of the root chain means that the group is bonded to the terminal carbon atom, right? And then so that's what it means. So the naming of it will be what we already know what the prefix will be, right? So the prefix will be yes, that's right. It will be our root chain or our parent chain, right? And then the suffix will be an al similar to alcohols, but where there's a mix of all. So, an example of how this looks like. So let's start with methanol, right? So methanol will look something like this, right? Right. Yes. Um, so this is methanol, and then we have this. So the carbonyl group will always be at the end, right? So let's actually, since we don't have much space here, let me just write it as a condensed structure. And then I'll just have this, right? So this one will be your what? Will be your propan, no, right? So for aldehydes, we can write that the functional group, because we know that the functional group is it's this, right? So something like this, right? So we can just say it looks like this. So this is the functional group for aldehydes, right? And this R here it just refers to an alkyne, right? An alkyl group or just an H atom, right? Because you guys, you can see for methanol, you have an H this side, but for propanol, you have a C this side, and that will be the same for ethanol, right? So that's just what aldehydes are. The functional group, the carbonyl group is at the end. It's placed at the end of your, um, at the end of your at the end of your chain, right? So this is the group, just to specify, that's the group, right? So let's just look at the counterparts, which are our ketones, right? Ketones. So for these ones, the carbonyl group uh, is placed within the chain. Let me just say parent chain, root chain, main chain, same thing, right? So it's placed within the parent chain, right? And now this looks will be something like this. So it'll be your C, double bond O, and then it will be your R this side, and then it will be your R this side, right? So this R could be a carbon atom, and this one could be actually both of them have to be a carbon atom, right? So this should be a carbon atom because for these ones, the functional group, let's just highlight the functional group, which is this, the carbonyl group should be within the chain, which means that it's bonded to what? To carbon atoms on both sides or to alkali groups, right? So, some examples of ketones. Actually, before we get to examples, let's just name them, right? So, what's the naming for this one? We already know what the prefix will be, right? So, let's just skip that. And then for suffix, it will be a one, right? So, these ones, for alkanes, you end with an E, right? Replace that E with a one, and then you have ketones, right? Let's just see how that works out. So, and since we have that rule that for these ones, the functional group should be within the chain, it means that you can only have a minimum of three carbon atoms, right? So you will have your carbon group there, and then it will look something like this. Okay, it seems like I'll be writing a lot of condensed forms to save a little bit of time. So this one, three carbon atoms, so it should be pro. So if it was an alkane, it would be propane, right? But it's a ketone, so it will be propan one, right? Propanone or propan one. So this is how you write it, and it's what is this general formula? Or chemical formula will be 3, so that will be C3H6, yes, because it's CnH2n, and then we have O. You can also write its condensed formula just to revive our memory, right? So this will be CH3, CO, CH3, right? So let's look at another one. So for this one, let's look at hexanon, right? So let's say we have CH3, CH2, uh, CO, and then we have what CH 2, and then the CH2, yes, CH2, and then CH3. 1, 2, 3, 4, 5. Right. So yes, and this the carbon atoms are 10, so it makes sense. So this one, it's a condensed structure, right? What will be the name for this one? So since you have 5, it will be a pentan one, right? And it looks like this. You can count them, it matches up, right? So that's what you have. You can write the chain like this. Um, and then this one will be a double dash there, and then you have this, and then you have this, right? So that's how you can do it. That's your structural formula, right? We just wrote this condensed formula because we've been writing structural formulas this whole time. So that's how you have it, right? We can also make this a little bit more fun, right? By let's see, let's just take this part, uh, copy it, and then paste it here somewhere, right? Because we want to reuse it. We just want to add some substituent there. So let's see, I add CH uh, 3, okay. Um, and then I have a bromine here. So we can tell that our uh, mention will be this one, because it should what? It should include the carbon group, right? The carbonyl group, the functional group. So the name in here, when we have substituent, we name them alphabetically, right? So it will be what? One, two, three, four. So that will be a four uh bromo, and then we have what? So we have two here, two methyl, okay, and then you have what? Pentane. Actually, I would really like to not have it as pentane. So let's have it as something else. Let's add another C atom. Yes, then we have Xa. So it will be Xa, none, right? Oh yeah, I can see it's an this. Let me just write it. Um, so this one will be Hexa. Right. So for our ketones, we don't really have to specify the where the double bond is, right? But so we just write them like this, right? Pentan, because for others like alkenes, alkynes, we have seen that you have to specify where the functional group is, right? But for this one, we've already say that the carbonyl group should be placed within the parent chain. So we know that it has to be within the parent chain. So it seems that it doesn't really change that much where you put it, right? Within, as long as it's within two carbon atoms, right? So I think that's the reason why we do not specify. So let's just recap. So we look, okay, I've gone back too far. We looked at the carbonyl group, right? Which is just a carbon atom double bonded to an oxygen atom. And their use is that they can be used to make flavors, pleasant smells, and solvents, right? The general formula is CnH2NO. And then there's two types. There's aldehydes and then there's ketones. Aldehyde is where the carbonyl group is placed at the end of the root chain, or the carbonyl group is bonded to the terminal carbon atom, right? And then the name means that the prefix will be a root chain, and then the suffix will be an R. Methanol, propanol, hexanol, pentanol, octanol. You see, that's how you write that, right? And then having the functional group at the end there. It's always at the end, right? And actually, the functional group is not the whole thing, but rather just this part, right? So ketones, the carbonyl group is placed within the parent chain, meaning that on both sides of the carbon atom, uh, that's the both sides of the functional group, you have carbon atoms, right, bonded to that carbon atom of the functional group. Suffix is one, so it will be the same naming for alkanes. You just replace the e at the end with one. You have propanol one. You have pentane, pentane one, and then you have hexane one, right? And then you can just make it a little bit more interesting by having what is this? By having substituents, right? Here with bromo and methyl. So yeah, that's our carbonyl functional group, organic compounds, right? It's very simple and straight to the point. Thank you.